Hey everybody, it's Eric. I wanted to create a video going over last week. Let's see, it is currently March 8th, 2025. I want to make a video going over last week's lessons regarding fractions since we had so many absences. And I do intend to put this publicly on YouTube. So if there is anyone who is not in my Adlife Academy math class, welcome. You're welcome to join us, but I'm going to be addressing specifically the students in my spring Adlife Academy math class 2025. And let's just kind of get started with a review of Tuesday's material. So I made a very clear effort to represent fractions as a part over a whole. So fractions will always be what part do I have over what is the whole thing if I had every piece. So for example, if I draw a circle and I cut it into 4 pieces and I shade 3 of these pieces, I can say the whole circle is 4 pieces. Okay, I'm gonna redraw that. I know a certain someone will get on my case if I don't change that 4. And the amount of the circle that is shaded is 3. So I can always consider my fractions to be what part I have over how many parts are there in the entire thing. So for those of you who are in my Adlife class, we did a little bit of this where I gave a worksheet that had certain, well, you know what, I just did 4. So let's do like, I don't know, let's do 6. There we go. Where I gave some problems where we had a shaded circle, and your job was to figure out what the fraction associated with that image would be. Then we also had some going in the opposite direction, where it's like, okay, well, if I have, say, 2/3, what does the circle look like that represents the fraction 2/3? Well, in this case, it'd be like this. So this would be a good thing to potentially practice. And if there are any parents looking and watching along with, this would be a good time to maybe pause the video and say, all right, let's come up with some practice problems for you to do. And you could have somewhere you shade in a certain amount of a circle that's cut into a certain amount of pieces, and you ask the student to, hey, tell me what fraction this would be. Or you can start with a fraction and ask the student to create a circle, to draw a circle, cut it into the right amount of pieces, and to shade the correct amount of pieces. So keep in mind that the fraction itself represents the part that is shaded, in this case, over all parts of the circle. So how many parts of this circle do I have overall, and then how many of those parts are shaded, and that will be the appropriate fraction. Now, on Thursday, I tried to make it clear that we can have multiple different fractions that mean the same thing. So for example, I'm going to take 1/3. So here's 1/3. And I'm also going to take 2/6. Now, my drawings could use some work. I understand that my drawings are not perfect. Notice that both circles have the same amount shaded, even though one is split into 6 and it has 2 pieces shaded, and 1/3 is cut into 3 pieces and has 1 of those pieces shaded. They both have the same overall amount of the circle shaded. 1/3 and 2/6 are equal to each other. They represent the same amount of stuff. In a mathematical way of speaking, we would say they have the same value. So there are multiple fractions that have the same value. As a matter of fact, 2/6 is not the only one that is like 1/3. I could also have 3/9, which I'm not going to bother drawing, and 4/12, which I'm not going to bother drawing either. I'd have 5/15, not drawn that, and so on and so forth. As it turns out, there's an infinite number of different fractions that I could write that would be the same as 1/3. 1/3, 2/6, 4/12, 3/9, 5/15, 5/15. All of these mean the same thing, which is very much unlike regular numbers. I can't necessarily look at one and say, well, there's another number that doesn't involve fractions that is the same thing as 1. I can't say 3 is the same thing as 1. I can't say 12 is the same thing as 1. There's no other regular whole number that I can say, that I can point to and say, oh, that's the same thing as 1. They have the same value. So this is sort of something that fractions have, that where we can kind of tweak what the fraction looks like, but it would mean the same thing. That is something specifically fractions can do that not regular whole numbers can do. Now, once again, if there are parents watching, this would be a good time to pause and maybe come up with some practice that has to do with matching fractions together. Say, hey, are these two fractions the same thing? And the way I would probably go about doing that at this level would be to draw what the fractions are in terms of shaded circles. That would be a good thing to pause and do at the moment if you would like, the student to practice a little bit. We're going to go ahead and move on though. If you paused, welcome back. But we're going to go ahead and move on, and I want to specifically talk about what happens if we shade all pieces. What happens if I shade every single piece? So this would be part over whole. So the whole of the circle, it's cut into 4 pieces. So I would put 4 at the bottom. That's the whole. The part that I have is also 4. 4 over 4 is my fraction. And you can, once again, bringing in our conversation from just a little bit ago regarding fractions that are equivalent, that have the same value. If I were to cut the circle into 3 pieces and then shade all 3 pieces, I'd have 3 over 3, which would be the same thing as 4 over 4. If I cut it into 6 pieces and shaded all 6 pieces, the same amount of the circle would be shaded, the whole thing. So 6 over 6 would be the same thing as 4 over 4. I can cut the circle into any number of pieces that I want, and if I shade every single one of them, they will all be equal to 4 over 4, or 3 over 3, or 2 over 2, or 6 over 6. They would all have the same value. Importantly, if I just took the entire circle and I said, I'm not going to cut it into pieces, I'm going to keep the whole circle, and I'm going to shade the one and only piece of the circle that I have, that gives me the fraction 1 over 1. All of the things I have just described also could have the value of 1, because I have one whole circle shaded in. So I want you to consider that one entire thing can have a fraction, which is like 4 over 4, 1 over 1, 2 over 2, 3 over 3, etc., etc., 100 over 100. But all of those things are representing one whole thing shaded in. So they are also all equal to the number 1. I'm going to draw a number line. So for those of you who are familiar, good. For those of you who are not familiar, a number line is just a way for me to arrange numbers visually, where I have like numbers getting smaller as I go to the left and numbers getting bigger as I go to the right. So for example, I'm going to say, here's the number 0, here's the number 1, here's the number 2. If you were with me in class on Thursday, then you will definitely be familiar with what I'm about to do here. I'm going to go ahead and represent these numbers with shaded circles. So 0 is a completely empty circle, nothing shaded. I have no parts of the circle. 1, as we just described, can be represented as a circle where the entire thing is shaded. And 2 is very interesting. You can pause if you want to think for a quick second on what you think the number 2 would look like. If you are ready, if you don't want to guess, or if you're already unpaused from your guess, I am going to consider this to be 2 entire shaded circles. So I have 2 whole circles. That is the number 2. All of the fractions that I have discussed, all of the things that have not the entire circle shaded, but some of it shaded, every single one of them, every single one of those fractions that you can think of, no matter how weird you make the numbers, if you have a fraction that represents some, but not all of the circle shaded, every single one of those lies here on the number line between 0 and 1. As a matter of fact, I would like us to see if we can plot some of these, if we can put some of these in the correct spot on the number line. So I'm going to give you 1/2, 1/4, 3/4, and 7/8. I'll change that 8. I'll change that 8. And I would like all of these to be put somewhere on the number line that is appropriate. I want them to be sort of in order, so we should get the idea that things that are smaller, meaning less shaded, are to the left of things that are bigger or more shaded. So this would be a great place to pause if you want to make the number line yourself. I'll give you a hint. You really only need to write from 0 to 1. I just included the 2 as like a way of showing you like, oh, here's how we would represent 2. None of the numbers up here are between 1 and 2. But if you'd like to, you can pause, you can make a number line yourself, and you can try to figure out where these numbers would go on the number line. If you're not interested in doing that, or if you've already unpaused, I'm going to go ahead and get started and show you how I would do this. 1/2 is like a circle, which I have half shaded. I have 2 pieces of it, and one of them is shaded. Notice that it's half this and half this. It's half 0, it's half 1. It would make sense that it goes exactly halfway between. I'm trying to make the circles smaller so they fit. Hopefully it still comes across and it still makes sense on your end. I know my drawings are not like necessarily like up to snuff, right? They're not the best, but it gets the job done, right? So 1/2 is exactly halfway between 0 and 1. It is exactly half shaded and half unshaded. If I look at 1/4, I cut it into 4 pieces. I shade only 1 piece. This is definitely less shaded than 1/2 is. It is definitely less shaded than 1/2 is. So it needs to go to the left of 1/2 to represent that it is smaller than 1/2. All right, so that much is shaded. 3/4. I don't know why I'm erasing this instead of just like, I don't know, moving it over. Because it's the same basic idea. I'm cutting it into fourths, right? I am going to shade 3 of those 4 pieces. And if I look at this, 3/4, 3 out of 4 shaded pieces, I see that it is more than 1/2. It is shaded more than 1/2. So because I'm shading more of this one, of this fraction, that tells me that this number, 3/4, is bigger than 1/2. So it needs to go to the right of 1/2. It's not completely shaded, right? It's not the whole circle. So it definitely doesn't go to the right of 1. It's not bigger than 1. But it is to the right of 1/2. Okay, 7/8. This one's really going to test me as far as drawing. Okay, so there's 8 pieces. I cut it into 8 pieces. I'm going to shade 1, 2, 3, 4, 5. Shade this one 6 and 7. Shading 7 pieces. If I look at that, that looks like it is more shaded than 3/4. It looks like it's more shaded than 3/4. Still not 100% full, right? I didn't shade the whole thing. I left a part blank, so it's not quite as big as 1, but it's more shaded than 3/4, meaning it is bigger than 3/4, and therefore to the right of 3/4. Yikes, I am really going to struggle to shade this in here. Okay, so there's 1, there's 2, there's 3, there's 4, there is 5, there is 6, there is 7. Okay, awesome. 7/8, got it. Now, I didn't necessarily do a good job conveying this, so maybe I'll pick an extra one. Oh God, maybe another good one. I'll do this. I will do 2/6. So 2/6 would be cut into 6, like that. Doing the best I can with the drawings, okay? And I want to shade 2 pieces. If I look at how that's shaded and look at everything else, I would say that 2/6 is right here. I would say it's not as shaded as 1/2, but it's more shaded than 1/4. More of the circle is shaded than for 1/4. So I would say that 2/6 probably goes right there. Now, I did that to convey a certain thing, and this will be new even for the people who were there on Thursday, although some of you may have already kind of come to this conclusion. 2/6 is smaller than 1/2. The fraction 2/6 is smaller than the fraction 1/2. For fractions, it does not matter if the individual numbers are bigger or smaller. The numbers 1 and 2 themselves are smaller than the numbers 2 and 6, yet somehow 1/2 is bigger. So sometimes fractions with smaller numbers as their parts can be bigger than fractions with bigger numbers as each of their parts. I want you to keep that in mind. And that will be the last thing I end with today. Hopefully that gets you thinking. Hopefully you guys will have seen this before you come back to my class on Tuesday. I look forward to seeing you. I hope you guys are feeling better. I know that there were a lot of absences. You guys were sick. And once again, I'm putting this, I hope, publicly on YouTube. So if there's anyone else watching, welcome. Hello. All right. That does it for me. I'll see you guys around. Take care.